So, picking up where we left off on the introduction to physical geography as part of nature and society, we looked at the various layers that might be in a GIS system. And one thing I wanted to say before we moved on from that is just that this is an area where quite a few people, graduates over the years from earth sciences and from geography, have found employment. And we do have classes in GIS. So, if you're interested in something like that, definitely something to look up. Um, so, in doing the whole field or studying the whole field of geography, parts of geography we would call scientific, where we use scientific methods. So, geography is methods, not just a body of knowledge. It's just not, oh, where are the lakes and rivers and streams and so on? Where are the mountains? It's actually as well a scientific discipline, and it has interactions and kind of overlaps with some of the others we'll look at in a minute. It's holistic, meaning that geographers like to kind of keep the big picture in mind as they ask questions and try to come up with answers to them. And as well, it's eclectic, which means that it may use a variety of methods to come up with answers to questions. And my master's thesis, I'm going to give you a really quick example of that, how it turned out to be this way. I was very interested. Much of my research has been in Latin America, particularly Mexico, but also in parts of South America. And I ended up doing for my master's thesis when I was at Arizona State University, I ended up looking at drought in an irrigated agricultural region in northwest Mexico. And I was very interested in what would happen during the dry years. How did it affect production? And so I started out with that question, which seemed fairly focused. So I had some very high quality data from a large irrigated region, about a third of the size of the Willamette Valley, so a pretty big agricultural area. And I had crop yield, and I had temperatures, and I had precipitation, so I could come up with drought from that. And one of the things that was really interesting is I kind of made an assumption that in drier years that the per acre yield would be less. That makes sense, doesn't it? It's dry, so you get less crop yield. Um, and so when I did the analysis, I had 23 years of data. I found out that that wasn't the case for the most part, that the per acre yields were actually higher. And I go, gosh, that doesn't make sense to me unless I think about this in a bigger picture. I had kind of approached it from what they call an agrometeorological approach, which is basically just to look at the plant physiology, what happens in drought, and you would expect lower yields. But what really happened was kind of thinking about this list here. Um, I had to have a bigger perspective to really understand what was happening. So, what turned out was that farmers in dry years, the farmers who had more political muscle, who had more influence, were able to get water. And they were also the farmers that tended to have the higher quality land. So if you look at yield per acre overall in the district, the farmers who during the dry years were able to get water uh, continued to have high yields, and the lower quality lands weren't even farmed. So the per acre yields were higher, even as the whole regional production dropped. Okay. So this is where in thinking that bigger perspective, I had to use a couple of methods. I started out with a kind of agro-meteorological approach, didn't really work. So I had to use more of a social systems approach where I looked at the power of different groups and realized that this was really more about distribution of water, not so much the physiological crop stresses that happen. So that's just an example of how geography, a lot of times we use these kinds of approaches to understand the world better. If I'd have just used the standard agro-meteorological approach, which I'd started with, I would not have really understood at all what happened in the system. Okay, so geography then is the science that studies the relationships among natural systems. So in this case, looking at my master's thesis, I was interested in this irrigated region in northwest Mexico. It was a dry region, but there was water that got stored up in the mountains and the reservoirs and then released for production. And that on top of local seasonal rainfall, those were the natural hydrologic systems. And then, of course, you have the soils there that were being farmed and so on. So emphasis there: atmosphere, hydrosphere, lithosphere, the farm system. So the natural systems, the geographic areas. In this case, the geographic area was part of the state of Sinaloa in northwest Mexico, and part of the North American continent. Societies, so very much society was an important part of this. How does power work when there is a shortage of water? That tells you something about society. It tells you about the different social groups and the power they have. Okay, cultural activities. In some cases, that can be important, and others not so important. That's not something that I spent time on in my particular work there, but that can be an important factor depending on where we are. Certainly, cultural was embedded in there, but I didn't really get into the details of that. And then finally, the interdependence of these over geographic space. Okay, so physical geography then is the spatial, or in other words, geographic analysis of all of the physical elements and processes that make up the environment. And in looking at this, this is a slide here that I will give you as part of the slideshow. I'm going to have some of these slides available for you, as I mentioned before. This is one of them. So please don't try to write this all down. And please know you don't really need to know all of these. But what I want to emphasize is, particularly in nature and society, we do a lot over here in nature, and we also do some society over here. But the emphasis on this is a little more in nature in this class. And if you look at these fields, biogeography, climatology, geomorphology, that's the study of landforms, hydrogeography, and so on, these are fields of physical geography. But they closely connect with others. For example, biogeography, not surprisingly, is about biology, and it's about ecology too, okay? Climatology would be about, let's say, meteorology, certainly. Okay, so you can see the connection there. Geomorphology is very closely connected to edaphology and also geology, and to some degree these other disciplines as well. And so you can see these what they call cognate or connected fields. Okay, so physical geographers have some training in all these fields. Usually they do specialize in one or the other, though. Okay, on the human cultural side, in the example of my master's thesis, some of this was just the history of the region, the power between different groups. Some of that has to do with political science and sociology, for example, that were part of the whole synthesis, the holistic view here, as it were, of that system that I described to you. Okay, this will be another slide that will be available for you, so you don't need to write this down either. This is a needlessly complicated slide, I suppose, in all of this. But if you just come over here on this side, let's look at this first. So physical geographers use scientific methods. They use them for prediction, explanation, observations, okay? Now, very often when we start in science, we start with observations, okay? And so you could say somewhere down here, there's a start and the scientific method. As you look at the very bottom of the screen here, what do we perceive? What do we know and understand? What do we want to know? And so we observe, okay? We observe maybe just with the naked eye. We collect data. In the case of my drought study, the data were the meteorological data of precipitation and temperature, for example, and then later crop yield to see how that connected with that. And so very often we start out with an idea of how something works. We maybe form hypotheses. I told you I certainly had some, okay? And one was that when it was drier, we would have lower crop yields. And generally speaking, that wasn't true because it was more about how the water got allocated, okay? And so I had to kind of go back and rethink a little bit how that system worked as I went through that. Okay, very common where we observe, we try to predict what's going to happen, but it's basically our hypotheses. And then we need to go back to the drawing board sometimes when we realize that we have not understood the system that we were examining very well. Okay, and so, and this example here, if you look right here, the example of carbon dioxide's ability to trap heat in the atmosphere. So you want to read part 1 of that link and listen to the audio embedded after you look at that link material above. So have a peek at that, and that'll be part of the slides that I post. Okay, so you might want to make sure and look at those slides. Okay, so that's I'll just open that quickly here for a moment. Okay, so this is what you should see when you go into that. Okay, now going back to our presentation then. What we want to do is move on to the next slide and talk a little bit about Earth systems concepts. So that holistic approach that we mentioned. And a system is just an ordered, interrelated set of things and their attributes linked by flows of energy and matter that is distinct from the surrounding environment. Okay, so in my case, this was a irrigation system. Okay, so it was connected to the atmosphere. There was flows of energy and matter in it, and so it was a particular region that I defined in my work. So within Earth systems, there are open systems where they have inputs and outputs of energy and matter, and for all practical purposes, that's all there really is. And then there's system feedback, where the outputs influence continuous system outputs via feedback loops. Let me give you an example of this. We're going to use this more than once in this class. System feedback is really important. And so ice albedo feedback works like this. Consider the Arctic. The Arctic, for parts of the year, is ice covered, not only on the land, but much of the sea as well. Okay, so imagine where you have, and this is something I would recommend you jot down in your notes. Okay, so it gets warmer in the Arctic, warmer than usual because of extra carbon dioxide in the atmosphere. All right, so we have some warming. What happens to the amount of ice in this warmer climate compared to when it was cooler? It's not hard to figure out. Probably less ice because it's melting, right? Okay, now when we have melting ice, what happens to the solar radiation coming in compared with, say, ice versus, say, open water or land if the ice was on the land? Okay, so ice is real reflective, isn't it? All right, so if ice essentially is kind of like a white surface, very reflective, when then it melts, either the land below it is absorbed or the ocean below, depending on where that ice is. And both of those surfaces will tend, in most circumstances, to have greater absorption of that solar radiation. Because of the lower reflectivity and greater absorption of the solar radiation, there is going to be a warming, more soaking up of the solar radiation, it gets warmer. So a warming Arctic has a positive feedback loop where it continues to get warmer. Okay, very important. Okay, I'm going to pause this here. Now, and in many cases, systems have a sort of equilibrium where the inputs and outputs are equal and the amounts of energy and matter and storage are fairly constant. Okay. Now, in the case that I just gave you, where we had ice albedo feedback as a positive feedback where it feeds on itself, in other words, we didn't have that. We had more energy now being absorbed by the system instead of that solar radiation being mostly reflected back out to space. Now more of it's being absorbed by the Earth's surface. That causes a warming, so the system is out of equilibrium. This would be a system as an automobile, just to give something we can all relate to. The inputs, fuel, oxygen, oil, water, tires, resources, yes, those good old payments that you make. The outputs, well, we hope mainly what we're trying to do is, what's the goal of that system, of all of these? Which one is really the goal? Why we built the automobile, why we use it in the first place? Of course, it's the mechanical motion. But there's all these other outputs too, okay? Most of it's heat. All right, so that then gets us to this very last slide. and we'll consider that slide in the very next one. We'll look at that.